Thank you for watching. Today we will introduce how to use our software to analyze data. First of all, you need to prepare the software in EDF format before using it. This is an open source software, which is used to analyze the data of wireless and Vivo electrophysiological telemetry system. Open this software. Let me briefly introduce the interface of this software. This small window is used to select the data of the recording channel you want to view. EG0 is the electrocardiogram. EG1 is the electromyogram. EG2 and EG3 are the electroencephalograms. If I want to look at two electroencephalograms, first select them, then click Add Signal below, and the spectrum will be displayed. The three ACCS below refer to the acceleration of the X, Y, and Z axis. They represent the acceleration of the mouse's movement. They are generally used to stage the sleep analysis of mouse because the stage analysis of the sleep of mouse requires three parameters: electromyography, electroencephalography, and movement. For other application scenarios, you can refer to the literature. In the options on the upper right, the amplifier button can adjust the vertical axis value. There are currently many ripples displayed. For example, if I remove the following ACCs, you can see that the current EEG coordinate range is 200, 400, etc. Similarly, in the options on the upper right, the timescale button can adjust the time value of the horizontal axis. The above are the commonly used browsing functions of this software, and the adjustment of the time axis and the electric wave axis. Next is our analysis software, AR Analyzer. For example, this is the data we downloaded from the server. The data number is 35,738. First, open AR Analyzer. Then click the Open button in the selection box and select EDF of BDF file. Select the data file 35,738 in the folder and open it. Click on the analysis model in the selection box. There are three analysis modes in this software. The first one is basic analysis. The second one is for myoelectric analysis. And the third one is for ECG analysis. The most commonly used ones are basic analysis and ECG analysis. Let's start with basic analysis first. After we select basic analysis, we can first see a waveform browsing box, just like EDF browser. The upper right corner of each waveform corresponds to the number of the corresponding channel. The numbers are, in order, ECG, EMG, EEG, and ACC channels of movement. This interface can be understood as a browsing interface. This interface is composed of 2,879 pictures. When you click the arrow below, you can turn the page to the next chapter. It is composed of 2,879 chapters. The time for each page to be displayed is fixed. Currently, it is 30 seconds. You can adjust the time by the epoch length option in the upper left corner. The amplitude can be adjusted by the amplitude in the upper right corner. This interface also allows time capture. When you import your data, the default time here is the start and end time of the data. When you want to view a certain node in the data, for example, we want to view the data from 22, 54, 51 to 1 hour later. I will enter the required time and click the Confirm button. Then the total data length here is this hour. This function allows you to select the time period you want to preview. Next, if you want to save an image in a local folder, you can use the Save button. For example, I want to save the pictures of this time period. Then I click Save, and a pop-up window will appear, asking you to enter the save address and file name of the picture. Click on the corresponding folder, and there will be pictures of each channel, and the pictures of each channel are separate. You can browse through them one by one. For example, this picture is EEG3. The resolution of this picture cannot be modified. You can only modify the fineness of the picture by adjusting the time and amplitude. It can save the picture you are seeing now. This is the main function of this browsing interface, including adjusting the time and amplitude, selecting the time period you want to view, and saving these pictures. Next is the introduction of analysis. There are 4 analysis functions, namely frequency band analysis, time frequency analysis, power spectrum density graph, and filter plot. Our commonly used functions are the above 3. Because the data we are demonstrating this time is large and the analysis time will be long, we select part of the spectrum for analysis. I change the end time to 15, which means the analysis time for this demonstration is 21 minutes. Click Confirm. All the analyzed data here are the data of the time length you selected in the lower left corner. Be sure to confirm. First, the demonstration frequency band power. When you click, there will be a pop-up window. This dialog box will let you choose which channels you want to analyze. Generally, frequency band power is aimed at EEG. EEG is EEG2 and EEG3 channels, so I choose EEG2. Conventional frequency bands include delta, theta, alpha, beta, and gamma bands. You can choose the frequency band you are interested in, or you can choose all of them. At the same time, it supports customizing a frequency band. I selected these 5 commonly used frequency bands. Confirm after selecting. The software analysis will take a while. After a pop-up window of Finish, the analysis is finished. Go back to the folder where the original data is saved. There will be a new Result folder. The analysis results will be saved in a subfolder under Result. The subfolder is named by the analysis date plus the time when the data file was just opened using AR analysis.
那一瞬间的时间。
The 4 result folders here are the analysis results I made at other times. We just did band power, so some graphs in an Excel spreadsheet will be generated in the corresponding folder. Let's look at them one by one. The first one is the average absolute per Hertz band power graph. It means that when I select 4 channels, each column here is the average of the absolute value of each frequency band. It is not very meaningful in application. The second one is the overall average value like the previous one, which is not very meaningful in application. When the name of the image is the name of the channel, such as channel 1, this image is the value of these channels and is a targeted and meaningful image. Channel 1 here refers to the first channel I selected when selecting the analysis channel just now. If I selected EEG0, channel 1 here is EEG0. If I first selected EEG2, then EEG2 is channel 1. The vertical axis of this graph represents the absolute value of the amplitude to frequency. We usually look at this bar graph of absolute amplitude values. This graph shows that during the period we selected, the energy of the beta band is relatively high compared to other bands. At the same time, the alpha band is the lowest. This is the band power analysis. At the same time, these data will be placed in an Excel folder, and you can use the data in Excel to draw a separate graph. This is the frequency band power analysis. The second one is the time frequency analysis, which can generate a time frequency graph for the time period you selected. Similarly, the first thing to select in the pop-up window is the channel to be analyzed. I chose EEG2. The parameters on the right generally do not need to be modified. The time interval is the horizontal axis, which is 300 seconds by default. Because the time length we selected is 20 minutes, the 300-second interval is enough. If the analysis duration is several hours, it is fine to add a 0 to the time interval of 300 seconds. Similarly, it takes some time to analyze and calculate. After running, a folder for time frequency analysis will be generated in the folder just now. Click it and a picture will be generated. This picture is the time frequency diagram of the 20-minute EEG we selected. The horizontal axis is the cumulative time rather than the actual time when the data occurs. The vertical axis is the frequency of the EEG, and the depth of the color here indicates the number of times the EEG frequency occurs. Let's take an example to illustrate the meaning of this picture. For example, at 15 minutes and 34 seconds, the EEG frequency at this time point is the darkest in this section, which corresponds to about 5 Hz. That is, at this time point, the EEG is mainly 4 to 6 Hz. Let's make a comparison and look at this place. At 15 minutes and 34 seconds, the highest frequency is only about 22 Hz. Above 22 Hz, there is almost no energy because it is blue. But at this time point, the EEG frequency band is about 25 Hz, which has 3 Hz more energy distribution than 15 minutes and 34 seconds. At the same time, at this time point, the energy distribution of 4 to 6 Hz is not as strong as the later. The time frequency diagram illustrates this meaning. You can also look at this area. The EEG frequency in this area is concentrated in the range of 0 to 12 Hz. This is equivalent to the theta plus alpha bands in the frequency bands we just selected. These two frequency bands are mainly related to sleep. They are medium and low frequencies without high frequencies. If you add ECG and motion analysis, this section may be sleep. This is time frequency analysis. Next is the power spectral density analysis. Again, when you click it, you need to confirm the frequency band that needs to be analyzed. We select EEG2. The frequency range here can be modified. We select the default one to 45 Hz. After a short analysis, return to the result file, and a PSD folder will be generated. An average and channel 1 graph is generated here. We click on the channel 1 graph. This graph shows the spectrum density during this time period. There are some small peaks indicating that there is some interference, which makes the curve not smooth enough. In this way, a spectral density plot is obtained. These are the three functions in basic analysis.